Kyle has drawn triangle ABC on this grid. Holly has started to draw an identical triangle DEF. What will be the coordinates of point F? So identical means exactly the same. So the triangle that Holly is drawing will be the same size as the triangle that Kyle has drawn. Now to get to point C from point A, that's across 1 and up 2. So we can go from point D across 1 and up 2, and we know that point F will be here. So with coordinates, remember we always write the x coordinate first. So if we go down, we can see that we have 4 as our x coordinate, and then if we go across, we can see that our y coordinate must be 3. So the coordinates of point F are 4, 3. This chart shows the favourite snacks of some boys and girls. How many snacks were chosen by more girls than boys? So if we look at the key, we can see that girls are pale grey and boys are dark grey. So if we look at nuts, we can see that more girls than boys chose this snack because the bar that's pale grey is larger than the bar that's dark grey. With raisins, we can see that the dark grey is bigger, so that's more boys than girls. For banana as well, the dark grey is larger. For fruit bar, we have just slightly more girls than boys because this bar at the top is slightly larger than the bar at the bottom. And for cereal bar, we have more boys than girls because the dark grey takes up most of the bar. So altogether, that's nuts and fruit bar, so that's 2 snacks chosen by more girls than boys. Now, how many more boys than girls chose raisins? So we can look at our bar for raisins, and this time we need to know the number of boys and the number of girls so that we can find the difference. Now if we go up and then go across, we can see that it's between 2 of these little lines, and each of these little lines must be an increase of 2, because to get from 0 to 10 we have 5 lines, and 10 divided by 5 is 2. So again we can find raisins, go across, and we can see that that's between 10 and 12. So that's 11 boys choosing raisins. Now if we look at the top of the bar and go across, we get to 18. So we need to find the difference. 18 minus 11 is 7, so that means 7 girls chose raisins. The total height of both parts of the bar is 18. We know that 11 are boys, and that must mean 7 are girls. Now the question asks how many more, so we're finding the difference, which means we need to subtract, and 11 minus 7 is 4, so 4 more boys than girls chose raisins. Now, which snack was chosen by twice as many boys as girls? So it's not going to be raisins, because 11 is not 2 times 7. But let's look at banana, because we can see just by estimating the size of the bars that the boys' bar is about twice as large as the girls' bar. So if we look across, we can see that 10 boys chose banana and 5 girls chose banana, because if we look across from the top of the bar, we have 15. We were already on 10, so that's 5 more to get to 15. And 10 is twice 5. So banana was the snack chosen by twice as many boys as girls, because 10 is twice as many as 5. The other bar that looks like boys might have about twice as much or twice as many is the cereal bar. But if we look across, we can see that 5 boys chose the cereal bar and only 3 girls, because the total is 8 and 5 plus 3 is 8. But 5 is not twice as many as 3, because 2 times 3 is 6, not 5. so we can't have the cereal bar. Our answer must be the banana. A square and a circle each stand for a different number. A square equals 34. 2 squares equals 2 circles and 1 square. What is the value of a circle? So we know that the squares are 34, so we can write 34 on our squares, and we need to remember that the equal sign means that we have the same on both sides. So on this side, we have 34 plus 34, so 68, and then on this side, we have 2 circles plus 34, so that has to total 68 as well. So we know that the 2 circles must be 34 altogether, because 34 plus 34 is 68, so giving us the same on both sides. So if 2 circles equals 34, we can find the value of 1 circle by dividing by 2, and 34 divided by 2 is 17, so the value of a circle is 17. If we write 17 on our circles, then we get the same, we get 68 on both sides of the equal sign. Use the dots to draw a shape that has 4 straight sides and no right angles. So remember, a right angle is like the corner of a piece of paper or the corner of this screen. And there are lots of possible answers for this question. But we could draw a shape like this because that has 4 sides and no right angles. This angle here is an obtuse angle. This angle here is obtuse as well. This angle is an acute angle, so less than a right angle. And this angle here is acute as well. These are the temperatures in York and Rome on a day in winter. How many degrees colder is it in York than in Rome? So if we look at our thermometers, we can see that the temperature in York must be 2 degrees because that's 2 lines above 0, and we know that each line is 1 because to get from 0 to 5 we have 5 lines, and the temperature in Rome is 2 above 5, so that's 7. Now it says how many degrees colder, so we need to find the difference, and we do that using subtraction. 7 minus 2 is 5, so it's 5 degrees colder in York than in Rome. Now, on another day, the temperature in York is 4 degrees. Rome is 7 degrees colder than York. What is the temperature in Rome? So, we have the temperature in York, 4 degrees, and we need to subtract 7. But 7 is larger than 4, so we know that our answer will be a negative number. From 4, we can subtract 4 to get to 0, but that's subtracting 4, and we want to subtract 7 altogether. So we need to subtract another 3, because if we subtract 4 and then 3, that's subtracting 7 in total. So 0 minus 3 is minus 3. So the temperature in Rome is minus 3 degrees. Here is a Venn diagram for sorting numbers. Write each number in its correct place on the diagram. So we need to place the numbers 10, 11, 12 and 13. If we look at our diagram, we can see that we have a large oval for multiples of 2, and then inside of that we have a smaller oval for multiples of 4. Now the reason why multiples of 4 is inside the oval for multiples of 2 is because all multiples of 4 are also multiples of 2. Every number in the 4 times table is also in the 2 times table, because numbers in the 4 times table are always even numbers. So first, let's think about the number 10. That's a multiple of 2 because it's in the 2 times table, but it's not in the 4 times table. So we need to write the number 10 in this section here. Now, the number 11 is not in the 2 times table and, of course, not in the 4 times table, so 11 has to be written on the outside. Now 12 is in the 2 times table and it's in the 4 times table, so we need to write 12 in this section here to show that it's a multiple of 4, but it's also, because it's in this section, inside the larger oval for multiples of 2. And now 13 is not a multiple of 2 or 4, so again we need to write 13 on the outside. Circle the 2 fractions that are greater than 1/2. So first we have 1/8. We can use equivalent fractions to find that 1/2 is the same as 4/8, so 1/8 is not greater. Now we have 6/10. 1/2 is the same as 5/10, and 6/10 is greater than 5/10, so we know that it must be greater than 1/2, because 1/2 is the same as 5/10. Now 5/8 is greater than 1/2, because 1/2 is equivalent to 4/8, but 3/10 is not greater, because for a fraction to be greater than 1/2, it has to be more than 5/10. Write these numbers in order, starting with the smallest. We have 8.12, 1.8, 8.118, 8.2, and 1.28. So here, I've written the numbers out with the decimal points lined up, because if the decimal points are lined up, then the place values in the numbers, so our ones, our tenths, our hundredths, and our thousandths digits will be lined up as well, and that makes them easier to compare. Now what we can do is write zeros in empty squares, so that all of our numbers have the same number of digits, so 3 digits, after the decimal point. And now we can compare these numbers in the same way as if we had whole numbers. So we start by looking at our largest place value, which here is our ones. We can see that 2 numbers have only 1 in the ones, so if we look across to the 10th, this number here has 8, but this number here only has 2. So that means 1.28 is our smallest number, and then we have 1.8. So our remaining 3 numbers all have 8 ones, so let's look across to the tenths. This number has 1, this number has 1 as well, but this number has 2. So one of these numbers with 8 ones and 1/10 will be next smallest. If we move across to the hundredths, this number has 2, but this number only has 1. So we know that this number here, 8.118, will be next smallest, and then we will have 8.12. That means 8.2 is our largest number, because that has 8 ones and has 2/10, and both of our other numbers with 8 ones only have 1/10. So notice a number with more decimal places, with more digits after the decimal point, won't necessarily be larger. So you can write zeros or write them out one below the other with the decimal points lined up, and then write zeros in empty squares. Or if you want to save yourself some time, what I like to do sometimes is just write zeros on the numbers in the question, so that they all have the same number of decimal places. So here they all have 3 digits after the decimal point. And then comparing decimals is just like comparing whole numbers.